Imagine burning a Ferrari every single day for 25 consecutive years. Sounds insane, right? But that's exactly what humanity did with the International Space Station. $150 billion, the most expensive structure in human history. More expensive than Portugal's annual budget. More expensive than building 300 Burj Khalifas. More expensive than sending 15 crewed missions to Mars. And here's the detail nobody tells you. Every single pound of this station cost $10,000 just in shipping. $10,000 per pound. That means a simple laptop on the ISS cost the equivalent of $40 million to get there. A chair, $1 million. So here's the question that should keep you up at night. How do you keep standing the most expensive and most fragile structure ever built by humanity? Let's find out. To understand why the ISS exists, you need to go back to the Cold War. Two superpowers, missiles pointed at each other. The space race was an extension of the arms race. But then, something improbable happened. In November 1998, Russia launched the first ISS module, Zarya. 2 weeks later, the United States docked Unity. And here's the miracle nobody talks about. These two modules had never met before. They were built in different countries, by teams speaking different languages, with different measurement systems, and they fit perfectly, with a margin of error measured in millimeters. At 250 miles altitude, and they created this 1 million pounds, 450 metric tons, traveling at 17,000 miles per hour. It completes one orbit around Earth every 90 minutes. You watch an episode on Netflix, it's already seen 16 sunrises, the size of a football field. But here's the detail that changes everything. The ISS isn't in empty space. It orbits between 250 and 260 miles altitude. That's low orbit, very low. And at that altitude, atmospheric molecules still exist. And that means one inevitable thing. The ISS is falling and traveling faster than a bullet. How doesn't it tear itself apart? The answer lies in the invisible villains. The ISS has 3 mortal enemies, and the first is invisible. When it enters direct sunlight, the external structure temperature jumps to 250 degrees Fahrenheit. 45 minutes later, it enters Earth's shadow, and the temperature plunges to minus 221 degrees. 16 times per day, every day, for 25 years. And that extreme heat would be lethal if it weren't for the second enemy. Right now, there are 34,000 pieces of space debris being tracked around Earth, and all of them are traveling at 34,000 miles per hour. A paint fleck at that speed has the kinetic energy of a .22 caliber bullet, and 2 ISS windows have already been destroyed. The solution? With one of the most elegant engineering solutions ever invented, the Whipple Shield. It works like this. When the projectile hits the first aluminum layer, it vaporizes, instantly transformed into a plasma cloud. 4 inches later, that cloud hits the second layer, Kevlar, and the energy is dissipated, absorbed. It's like parrying a punch. You don't block, you dissipate the energy in 2 stages. But there's a bigger challenge. Commander Chris Hadfield spent 166 days aboard the ISS, and in his masterclass, he explains the orbital physics that defies intuition. It's the manual that real astronauts use. But there's an even more silent villain. At that altitude, atmosphere still exists. 1/1,000,000th of sea level pressure. But it exists. And when you're traveling at 17,000 miles per hour, even 1/1,000,000th of atmosphere creates drag. Enough drag to slow the station down. and make it lose between 160 and 330 feet of altitude per day. Without correction, it would burn up in less than 2 years. So every 30 to 60 days, the Russian Zvezda module engines fire and push the station back up. Each maneuver consumes hundreds of pounds of hydrazine, toxic fuel. Extremely expensive, it's literally a floating gas station worth $150 billion. But there's an even more insane detail about the ISS, and it has to do with how you turn 1 million pounds without burning a single drop of fuel. Imagine this problem. You need to turn the ISS 180 degrees. So the engineers used something far more elegant. Pure physics. 4 giant gyroscopes, CMGs, Control Moment Gyroscopes, spinning at 6,600 rotations per minute. By tilting their axes, the station rotates in response. It's like a cat flipping in midair, redistributing internal mass to change orientation. But rotating the station is only part of the problem. How do you breathe for decades without opening a window? OGS system, water electrolysis, splits H2O into oxygen to breathe, and hydrogen vented into vacuum. But there's an awkward detail. The ISSE CLSS system recycles all station fluids. 93% of fluids, urine, sweat, air moisture, and it comes out purer than tap water on Earth. So yes, the water you drink on the ISS today was someone's pee last week. And there's the most precise engineering of all. The challenge: unite 2 objects with massive inertia, both traveling at 17,000 miles per hour. First phase, soft capture. Hydraulic shock absorbers dissipate the impact. Margin of error, 4 inches. Approach velocity, 0.3 feet per second. Second phase, 12 steel latches create the hermetic seal. It's like parking a 20-ton truck in a 21-ton space, while both are on a roller coaster at Mach 22. And that's how you keep humanity's most expensive structure functioning. The ISS is not a monument to human invincibility. It's a monument to obsessive maintenance. Engineers on 5 continents keep it alive because the ISS proved something nobody expected. Humanity's greatest achievement wasn't building it. It was not letting it fall. If you want to have this engineering miracle on your desk, the LEGO Ideas International Space Station set is the most technically accurate replica ever made. Each module clicks together. Each solar panel articulates. It's a reminder that we're the species that does the impossible and then fixes it when it breaks. Engineering is about fixing what matters. $150 billion, 1 million pounds, 16 countries. And all of this to prove one simple point. When physics says impossible, engineering answers, for how long?